computer. Okay, so we're back from the break. And let's go to material, just a second. Software engineering, lecture 2. By the way, all of my slides are on Moodle. Feel free to download them, print them, and write notes on them, which is a useful way to study, not to write everything that I say, just write anything I add. Where share screen, okay. Okay, so there's something project initiation, which means starting a project. The steps involved in starting a project, software project. So first, we're going to define what is the difference between methodology and techniques. It's kind of like, definitional here. Methodology is how to do something. Technique is how to implement that methodology. So you can have different techniques for the same methodology. That's the main point. The technique is more detailed. It can be different techniques to follow the same right. Example, make a list of the functionality of a system. The methodology might be object-oriented programming. Technique might be to use a class diagram. In other words, object-oriented programming, I could use different things in a class diagram to show the functionality of the system. I could use a sequence diagram, other diagrams that we haven't learned yet. So there's different techniques to follow the methodology within object-oriented programming. If we use the methodology of structured analysis modeling, which is a precursor to object-oriented, or we might use the technique of making a data flow diagram. A data flow diagram, we're going to learn how to do that. By the way, in that first chart that I showed you, there was no data flow diagram in it. Data flow diagram is not part of UML. It is part of structured analysis modeling, which is older. In UML, the activity diagram typically takes over the role of the data flow diagram. Well, we're going to make data flow diagrams, and I think we're going to make activity diagrams, or at least sequence diagrams. Now, so that's just methodology. That the methodology is more general, and the technique is a particular thing. Tools for software development. So we have CASE tools. CASE stands for computer-aided software engineering. As opposed to CAD tools, which are computer-aided design. For example, in a PC environment, we can create diagrams using the programs Visio or Whitestar or even Rhapsody. An IDE, all right, now this is an important thing. An IDE, an integrated development environment. What is an IDE? It is an integrated development environment. In other words, it's an environment for you to develop, for you to write software. You're familiar with one, Visual Studios. There are other ones, NetBeans, Eclipse. Probably you're going to use Eclipse in your mini project in software, in Introduction to Software Engineering mini project. That's going to be in Java, and you probably will use Eclipse.
I think usually
or VS Code.
Yeah, you can use whatever you want, but it comes with IDE comes with a editor, a compiler, a debugger. Yeah, just think of some other term. Fine. Then there's project management tools, such as GitHub or Subversion, which are for sharing code and also for version control. Sharing code means that I should be able to see what you're coding right now, even though you haven't, well, I mean, actually, until you push it, I won't see it. But if you add things to the program, in other words, we should be, it enables collaboration. you know, if you're just writing something in your IDE, how is it in the whole, how do you put it into the whole system that we're building together? So you have to move the file there. So instead of just moving it directly, you use something called Git. I don't know why I wrote GitHub. I really should have just said Git, right? Anyone agree with me or disagree with me?
I agree with you.
Correct.
Yeah, Git. GitHub is a particular website or something, but view, present. So these things, they enable you to push the file and then unpush it if you made a mistake. Let's say you added it to the source space, and then it caused the whole system stopped working. You can revert, go and remove all your code, and the system will go back to the way it was. So that's one major advantage of Git in Subversion. Another thing is you can know exactly who pushed what. If you find a bug and you see it's in somebody's code, you know who has to fix it. In general, version control allows you to step back when some error happened. That's the main purpose. When an error happened, you can revert back to a previous version that you knew was stable without having to go and delete files or whatever. It automatically, you could write 25 files and push them in 25 different directories. And when you revert, you can remove all of them or even just one of them. Anyone want to add another advantage that they can think of for why we use these version control devices?
They usually allow for branches, so I can work on one thing without affecting you.
Right.
Still have everything shared.
In other words, I can have the whole code in front of me and start adding stuff to it. And the fact that I change it and now everything breaks doesn't get to break it for you. I just broke my version, my branch of the code. Like I have a copy of the code and and you have a different copy. And when I want to, right. Still, how would you do it otherwise? You would have a copy either way. You'd have a copy. Nobody would work directly on the same thing. You would have a copy, but it would be more, you'd have to copy the files over. I'm just thinking, how would you work without such a thing? You would have everyone would have a whole complete copy of the entire system, and they would make changes, and they'd have to remember all the changes that they'd made. They'd have to know all the changes that they'd made and copy them over to the main system. But how would you remember that? So the main thing is that Git allows you to know what's been modified to compare your version to the original version, to the current version. And then you know what exactly was modified, and you can only move changes over. It automatically lets you do that. It's extremely useful when you're working in a project. Collaboration and task division tools like Azure DevOps and Kanban and Jira provide the following. So these are tools specifically for collaboration, task division. In other words, I want to know who's doing what part. And I don't want to just have you working in Git and I find out what you've been doing when you finally push your code into the general code. I want to know ahead. I want to be able to, as a manager, see what things you're supposed to be doing. So Kanban or these other programs, they allow me to manage tasks and assign tasks. Project manager, documenting the requirements, tasks, bugs tracking, monitoring progress and reporting. Source control, allowing collaboration, retain history, build and deploy, manage releases. Right. This is what I was saying. When you're finally ready, you can build it, you can add it to the main repository, and now it becomes part of the source code. So all these things are designed, I didn't get in a lot of detail. Really, when you get a job, you'll really learn about it, or when you're, but actually in the mini project, you'll probably use Git. Okay. Project initiation. Define what the project will do. This is when you're initiating a project, you should define what it'll do based on what client describes and needs. Right? You're not just going to, if you have a client, if it's a product, in other words, for general consumption, then you may have the product manager will describe what it needs to do. Create a document which will you see, I wrote this a little bit too fast. Create a document which will act as a contract. What will be provided, by when, and at what cost? Wait, there was a mistake here. Mafteach. So mafteach, as the name sounds, is Hebrew. And it's similar to that SRS. Remember we talked about the SRS? System requirements. What does it stand for? System requirements.
Specification.
Specification. Thank you. You guys are smarter than I am. System requirements specification. So it specifies what the requirements of the system are. So you have to read it backwards. Specify the requirements of what the system is. System requirement specification. So it's similar to an SRS, but it's an Israeli standard template for creating software software project description. It's mafteach is like Rosh Tevot of Mizgeret, Pituach, B'tachzuka. And that's mafteach. So it's just a standard format. It's a template for how to write the SRS, essentially, the system requirement specification. It's created by a company called Methoda, which still exists, and the Israeli Department of Treasury, which still exists. I think so. Mafteach defines several documents. So there's not just one document in it. It has several documents. It has a project initiation document, which actually we'll be doing in the lab. Wait a second, is this the lab?
No, the lab's
No,
on Sunday.
The lab's on Sunday, sorry. Okay, the lab's on Sunday. So project initiation documentation we're doing in the lab. It also has a specification document, a design document, a coding document. See all the stages: design, coding, maintenance document. We will focus only on the project initiation document. Okay. But all that is part of Mafteach. System tree according to Mafteach, showing the life cycle of a project. So, wait a second, I want to do something. I don't like this. What if I do, what does this do? Spotlight. Now I spotlighted? Something
There's
changed?
nothing. No.
No? Wait a second. I don't know what that does. I thought that. Okay, sorry. So this is the system tree according to Mafteach. We have here, you got to read on the bottom here. Initiation stage, specification stage, design stage, evaluation stage, maintenance stage. That's the life cycle of the project. According to waterfall, remember, this is waterfall because Mafteach is for government members of the Department of Treasury, and it's for government projects, which are going to usually follow the waterfall thing, because waterfall design, because we want to know everything ahead of time. But so there's going to have these stages of the project development, and then in those stages, you could talk about the goals. In the initiation, the goals are partially defined. The application has a general idea of what the application will do, or how the application will be done. You have not defined your technology, but maybe some constraints will be defined. Like, you can't use more than this amount of memory or something. Implementation, you might have a preliminary implementation. Cost, you have initial estimates. Then your goals, by the specification stage, you've already got your final definition of the goals. So here it says not changed because your goals are finally defined. Then you know, the application is mostly defined. Technology, you're discussing what the architecture of this whole thing will be. Anyway, this is just showing at, I don't really want to go into this too much, but this is just showing at the different stages what things should be, what stage each of these aspects should be at. Like you see, the costs will be an estimate, final estimate, budget check. You check with the, you make sure it fit into your budget and it didn't go over budget. Then you have maintenance. You have special maintenance costs. Whatever. You don't have to remember this table. But here we're going to explain sections of the project initiation document. So this is called the Mismach Yazum, which we'll do in the lab. The standard defines sections and subsections and what their contents need to be. So the goals defines the goal. Remember, we just saw the goals, the application, the technology. These are all the things that we just saw. The goals defines the problems that the system will solve. Obviously, okay, that makes sense. Application, what functions will it have? Who will use it? So it's like, I guess we could, applications is what like features we would say. Technology and infrastructure, what the operating system what operating system will you use? What hardware will you use? Implementation. Who is responsible for the implementation? Who are the team leaders? Who is in charge of integration? Costs. Cost is mostly salaries for programs. We need to make an estimate for these costs. There's also a zero section for a summary for the managers to read. In other words, there's a section which is zero, which you don't have to actually have. But if you want it, it could be like a short version of the whole thing. By having set locations for each topic, we know where to look for something, and we avoid forgetting to include something. Right? If we have all these sections, we have to fill them all out. We'll be sure to have everything mentioned, and we'll know where to look for it. Again, so I want to go back to the previous thing. I think I said it a little bit wrong. This is not really the life cycle. I don't know, so I might be wrong about that. It's not really the life cycle of a project. It's really the sections. Oh, it is showing the life cycle, because here's the life cycle. So according to this, the document will change in time, according to what's written here, because in the initiation stage, the goals section will not be fully defined, but it will be fully defined later in the specification section. Defining what technology I'm going to use may not be defined at all. Here, I'll define what the architecture will be. Here, I don't know why it says purchase. What I will purchase, I don't know. Maybe I actually do the purchasing. I'll purchase what I said I need to purchase in the design stage. So it's a complicated table here. Initiation phase is done by the business analyst or systems analyst or both. Yeah, systems analyst is a person who defines the system, designs the system, or designs how a system should be. A business analyst is more like, he's the person who talks to the client and figures out what the client needs. So either one could do this. He or she needs to analyze the present condition of the system if one exists, the work environment, the existing technology, the time constraints, the budget constraints. Goal is to try to decide if you want to do this project and to convince the investors to fund this project. In other words, we're doing it sort of like a feasibility study, right? We're trying to see if it makes sense to be doing this project at all and how much it will cost. And if we're paying for it, we want to decide if we want to do it. If we're not paying for it, we need to convince investors to pay for it. So we need to show them how long it'll take, how much money it'll cost, and what they'll get from it, what features it will give. Data is collected from existing system. Now, there could be an existing system. We might go around and talk and see how the system works. We may look at similar systems that already exist, similar documents that already exist, plans already written, and we may speak to the workers who are currently working there to see how they want the system to work. Remember, we're talking about something for like, again, the best example to think of is like, managing a library, the information system that would manage the checkout of books and the purchase of books and keeping track of late fees and things like that. Final product is the initiation. So when I'm all done analyzing everything, I can write this initiation document. In Hebrew, it's called a mismach yazum. Yizum. Let me just add something here. What happened? Okay. After getting the project initiation document, we might decide to do the project and proceed with the next step, the specification. Or we might decide to cancel the project. Or we could decide to improve the initiation document. We could decide it's not good enough, it's not well done, it's not accurate. Normally, we would decide to do the project and proceed to the next step, which is specification, exactly how it will be done. Okay, so now I say, see Hebrew slide section 2, slides 26 to 64. So here I have to go to Moodle. It didn't translate everything because, wait. Let me stop the recording.